So this one is question 2 from exercise tool of light. Figure 6.1 shows a protector superimposed on a path of a ray of a light. The light is traveling in a glass towards a boundary, as you can see. Using a protector, measure the angle of the incidence. So how we can measure the angle of incidence? First, we should draw a normal. Because angle of incidence is always measured from the normal. So this is the normal. So this angle is angle of incidence. How much is this? What is the angle of incidence?
So it's 125 minus 90 equal 35.
Yeah, or you can also measure, like example, 90 to 80, it's 10, 20, 30, and then 35. So this angle is 35 degrees. So the angle of the incidence equals to 35. Because we always measure, like a common mistake, student just read from 0 to 60, here 55, and they say angle of incidence 55. That's wrong. Because angle of the incidence is always measured from the normal. So whenever you are measuring angle of incidence, it should always be measured from the normal. So angle of incidence in this case is equal to 35. The next part, calculate the refractive index is 1.56. Calculate the angle of refraction. So here the light first, where it is moving from glass to air. So if it is moving from glass to air, what will the formula for refractive index in terms of angle?
Sine R over sine I.
Sine I.
So it will be sine R, the angle of refraction over angle of incidence, that is equals to refractive index, because moving from denser to rarer medium. So refractive index is given 1.56. Sine R we are finding because we want angle of refraction, and angle of incidence we don't know. So we write as, angle of incidence is 35, angle of refraction we don't know. So this sine 35 is there, divided, other side will be multiplied. So 1.56 times sine 35. What is the answer for this? 1.56 times sine 35. What's the answer?
0.89.
So 0.89 is equals to sine R. We need R. So we'll take us, when sine move to other side, becomes sine inverse. So it will be sine inverse 0.89. What is the value for angle of refraction? It should be higher than incidence.
62.8.
So 62.8. Or we can also say 63. Is it clear, this example?
Yes, sir. Clear.
Yes, sir, clear.
The next one, state what is meant by critical angle. The definition you have to learn for a critical angle. Critical angle, the angle of the incidence is known as critical angle for angle of refraction (90 degrees) when the light is traveling from denser to rarer medium. So the angle of incidence is known as the critical if the angle of refraction is 90. The block is made from a particular type of a glass. Figure 6.1 shows the light passing from air into a glass. What is the angle of incidence here?
90 minus 29.
So angle of incidence 90 minus 29, which is?
61.
61.
So angle of incidence is 61 and angle of refraction is 33. So angle of the incidence is always measured from the normal. Like here, it's written 29, but it's not 29 because we always take the angle from the normal, which is 61. So using information from figure 6.1, calculate the refractive index. It's moving from air to glass. What will the formula for refractive index?
Sine I over
Sine
sine
I
R.
over
I
sine
over
R.
R.
So it will be sine I over sine R. The refractive index, we are finding the angle of the incidence. We will put 61 because that is this is 61. And the angle of refraction is 33, sine 33. What's the answer? Sine 61 divided by sine 33.
1.6.
1.6. So we'll write 1.6, and refractive index does not have any unit. So don't write any unit as it's just a ratio. The critical angle, how to work out a critical angle, the formula which relate the refractive index and critical angle, that the formula n is equals to 1 over sine c. That is the formula, remember, which relate the critical angle with the refractive index. So n is 1 over sine c, or we can say sine c, other way around, we can say sine c is 1 over n. So sine c equals to 1 divided by 1.6. What's the answer? 1 divided by 1.6?
0.625.
So 0.625. And but we need the critical angle. So if you need a critical angle, sine move other side. So C equals sine inverse 0.625. Sine inverse 0.625. What's the answer?
38.6.
38.6. We'll write as 38.6 degrees. That is the critical angle. So from refractive index, if you want to work out the critical angle, we can use this formula. Both are the same thing. I just make a subject as refractive index, another one as a critical angle. State one application of optical fiber. Draw a diagram to show how optical fiber is used in this application. You can mention endoscopy. You can also mention for communication.
Communication.
The communication is by, now, because as you will find the new syllabus, 38.68. So okay, 38.7 will be there. That one. So you can draw a diagram. You can mention light and like information in the form of light travel or undergo total turn reflection. And using the optical fiber or fiber optic, we can communicate, like sending signals in the form of light, or data or information in the form of light. No, it won't be considered as wrong, because this is an open response question in which you have to just mention or use of optical fiber. So it's an open response question. So even if you write endoscopy, it's not considered as wrong. Any relevant use you can mention. A ray of a light in a glass is incident at a boundary. What happened to a ray of a light when the incident ray, like a ray of a light in a glass, is incident at a boundary with air? So like light is there in a glass, and it strike the glass to air boundary, but the angle, this angle is less than the critical angle.
So it will refract.
So as a result, what will happen? Refraction of the light will occur. It will refract because the angle of incidence is less than critical. So it will just change its direction, bend away from the normal. And very small amount will, yeah, that's right, very small, mostly it will refract. And very small amount or very small proportion of a light will reflect. If it is greater than critical angle,
Total
right?
internal
All of them
reflection.
Move at 90 degrees.
reflect.
No, it's that, yeah, the question is, Muhammad Ashraf, the question is, it is greater than, if what you're saying travel with 90, if it is equal to critical. But they mention here it is greater than critical. So there will be total turn reflection, or all the light will reflect back. If it was equal to,
Sorry, Mr. I thought equal.
yeah. So it will be total internal reflection, because the angle of the incidence is more than the critical angle. The next question, figure 6.1 shows a ray of a light incident on a glass. The critical angle is 42. On a figure, without calculation, continue the ray of a light until it leaves the glass. First thing, we'll draw a normal. When we draw
It
a
will
normal,
bend away from normal.
First, when we draw a normal, what will be this angle?
60.
60.
60 because 90 minus 30.
So it means this angle in the glass is 60 and they mentioned the critical angle is 41. So what I should do? I will draw a light ray reflected back. Why I draw a reflected back? Because this angle of the incidence is more than 41.
Incidence more than critical.
Yeah, so more than critical, that's why total turn reflection. Then I will draw a normal again. Is it clear, the first one?
Yes.
Yes, sir, clear.
And the second one, we'll draw a normal again on the other side because this will be the normal. So this angle will be 30. Okay, yeah, sure, I will explain the first part. See, the question is, the critical angle is 41. What does it mean? Critical angle is... What does it mean? The critical angle is 41 means if this angle is 41, the light will travel at a 90 degree to the surface. So if this angle is 41, it will travel 90 degree. If this angle is less than 41, it will refract. And if this angle is more than the critical, like example, more than 41, so it will reflect back. So when we work out the angles here, because we don't have to do calculation, we just have to work out the angles. When we draw a normal is always perpendicular or 90 degree to the surface. So if this angle is 30, how much is this angle? This will be 60. So if this is 60, it means this angle is more than 41. If this more than 41, what will happen? There will be a total internal reflection. So light will reflect back in the same medium. That's why I draw the reflected one. Is it clear till this point?
Yes, sir, clear.
Now, the second angle, how I can work out the second angle when I draw the normal. When I draw this normal for a triangle, the total sum of the angles should be 180. This angle was 60, as we already know, because angle of incidence and angle of reflection should be same. If this angle is 60, this will be 60, and this is 90. So how much angle is left out of 180? If this is 60, this is 90, so we are left with 30 only. That's why I put this as a 30. Now this angle is less than the critical because critical is 41. This is less than critical. So light will refract and it will bend away from the normal. Any angle you can make, but more than 30, that it bend away from the normal. So that's how we have to complete a path. It is not to scale, so don't use a measurement. For a length, you cannot use a length as a measurement. Is it clear, this one? How to complete a path of this light? Angle of refraction, this angle can be any value,
Yes,
but
sir,
it should
clear.
be more than 30. This angle can be any value, but it should be more than 30 because the light is moving from glass to air, so it should bend away from the normal, so the angle should increase. Then calculate the refractive index. How to work out a refractive index? We have the critical angle. So we simply use a formula n is equals to 1 over c. So refractive index is 1 divided by sine and critical angle is 41. For what is sine 41? What is the value for sine 41?
0.656.
0.656. So 1 divided by 0.656.
1.5.
So 1.5. So the refractive index equals to 1.5. So we have the critical angle. We work out the refractive index. The next question, the speed of a light is 3 into 10 to the power 8 in air, and speed of a light in a transparent liquid is 2 into 10 to the power 8. The angle of the incidence is 40. First, we need a refractive index. We have the speeds. What's the formula for refractive index?
Speed of light in
in
air
vacuum
over
over
speed of light in medium.
medium.
So speed of light in air divided by speed in a medium. As you can see, the speed of a light in air is same as speed of light in vacuum, as approximately same. That's why. So this will be 3 into 10 power 8 divided by 2 into 10 power 8. When you divide the two speeds, it will be 1.5 without any unit. And ray of a light is incident, the angle of incidence is 40. Like it moved from air to liquid, so the formula for refractive index, that is n equals sin I over sin R. So refractive index is 1.5, we calculated in the previous. Sine angle of incidence is 40 and angle of refraction we don't know. We cross multiply. I'm solving it here. So sine R equals to sine 40 divided by 1.5. What is sine 40? Value for sine 40, 40. 0.64.
0.64.
0.64.
So 0.64 divided by 1.5. What's the answer for this? 0.64 divided by 1.5.
0.426.
0.426. So 0.426, that is sine R, but we need R. So R is equals to sine inverse 0.426. Sine inverse of 0.426.
25.2.
And it is obvious because the speed is decreasing, so angle of refraction should also smaller than angle of incidence, so it will be 25.2. Figure 7.1 shows a side view of an object at the bottom of a tank of a liquid. Light travels slower in this liquid than in air. On a figure, draw two rays from the object into air and use this to locate an image. Look how we locate an image. First, the two rays we will draw from object. First, moving from liquid to air, it will bend away from normal. Then another one, moving from liquid to air, it will also bend away from normal. So as a result, what will happen? Our brain senses that the light is coming straight from the object. So when it produces these two backward, the position, the point where these two light rays will meet, that is the position where the image will form.
Shouldn't the refracted rays look parallel?
No, refracted, not necessary. It can,
Okay.
it's not necessary. Even if it's difficult to do, if you draw parallel, for example, as you're saying, I should draw parallel. If you draw parallel, you cannot meet them. Say if you draw a parallel light ray, because you want to intersect them. So if I draw parallel, they will never intersect if I join from here. So better the angle between them should be increasing when you draw. So first, the second one again also bend away from normal. But when these two light rays, we produce them backward. As our brain sense light is coming straight. So this is a position where this object will appear. That's a new position or apparent. What kind of image is this? Real or virtual?
Virtual.
Virtual. This is just imagination. In reality, if it was a real image, then the two light rays which are coming out from the water should meet or intersect by themselves to form a real image. Is it clear, this drawing? How the image is formed?
Yes, sir, clear.
There is one complete exercise is there. It's about like 50 to 60 pages in which I sort out all the ray diagrams related to waves. That I will share with you as a next week homework. So you will do that. And I already have like recorded all the explanation of that exercise. So I'll share that with you coming week as a weekly homework. A red light traveling in air strike a curved surface, a semicircular glass block. Figure 8.1 shows a ray of a light. Explain the light travel in a straight line from O to Q. It does not change the direction. Why it does not change the direction?
Because it passes along the normal.
Along the normal.
Passing along the normal or angle of incidence is 0, so angle of refraction should also be 0. But the best most simple possible answer is was passing along the normal. Because when the light is passing along the normal, it will not change the direction, it only changes the speed. Then a light travel in a glass at Q, where it strike the edge at an angle of 30, as you can see. Refractive index is 1.5. We need the angle at which the light emerges. First, it is moving from glass to air. What will the formula for refractive index?
Sine R over
Sine
sine
R
I.
over sine I.
So it will be sine R over sine I, because moving moving from glass to air, it will bend away from normal. But so this will be 1.5. Angle of refraction we don't know, and the angle of incidence is 30. So this will move there. 1.5 into sine 30. What's the answer for this? Sine 30 times 1.5.
Equals 0.75.
So that is 0.75 is equals to sine R. But we need R, so sine will move other side, it becomes sine inverse. So sine inverse 0.75. What's our value for R?
48.5.
So 48.5, and we have to draw that refracted ray at an angle of 48.5. Because I think the next question is draw the path of a the direction of a light striking the curved surface is changed, and the angle between the ray and the normal is gradually increased from 30 to 90. Describe what happened to the light that strike the block at this angle, increasing angle. Like what we are doing, first we strike with the 30, then we strike with 40, then we strike with 50, then we strike. So we are increasing this angle. So as a result, when the angle will increase, like when the angle of incidence is increasing, the angle of refraction will also increase. Like when it is 30, maybe it was 48.5. When it is 35, it refract more. When it is say 40, it will refract more. Like it will travel at a parallel to the surface. That will be the critical angle. And then if we increase the angle more, then it will undergo total internal reflection. So how you write the answer here? First thing, as we increase the angle of the incidence, the angle of refraction will also increase. That will score 1 mark. Like increasing the critical angle is there for any material. So first, what will happen if as we are increasing the angle of incidence, the angle of refraction will increase. And at certain value of angle of incidence, the angle of refraction will be 90. And that is known as the critical angle. When the angle and when the angle of the incidence is more, or when the angle of the incidence is more than critical angle, the total internal reflection will take place. Means all of the light will reflect back in the same medium. Is it clear, this answer?
Yes, sir, clear.
Okay. Figure 7.1 shows a in a total interreflection, the refracted, like what actually happened, as if we increase this angle, like first it was 30, then angle of refraction was 48.5. If we increase this angle of the incidence, the angle of refraction will also increase. At a certain value of angle of incidence, the light will travel at a 90. That angle of the incidence is known as the critical angle. It is also a refraction, and if the angle is more than the critical, all of the light will reflect back in the same medium, and we call that as a total internal reflection. So the refraction turned into reflection if the angle of the incidence is more than critical angle. Yeah, when it move out, there will be a refraction. That will be refraction. When it is going out, that's fine. But we talk about what happened to a light ray within the glass, or on the boundary, what happened to a light ray. That we have to mention. Then here you have to do, the box contain two identical prisms are there. On a figure, complete a path of a light through a prism. Light undergo total turn reflection. So if it undergo total turn reflection, like the light will pass straight here because it is passing along the normal. But this angle is more than the critical, so it will reflect. So it will reflect, like, because this angle is more than what should happen to a light? It should refract or travel at a 90 or total turn reflection. But they mentioned that in the first prism, like there's a total turn reflection, so it reflect back. Then there's another prism is placed and light strike undergo total turn reflection. So when it strike the denser to rarer boundary, it undergo total turn reflection and this light will emerge out from the other side. Because in this one, this is a normal. The normal is perpendicular to the surface. So this is a surface. These two angles should be same, the angle of incidence and reflection. And again, when we draw a normal here, these two angles should be same, the angle of incidence and angle of reflection. So light undergo total reflection in both prisms and it emerge out on the other side. Is it clear, this one?
Yes, sir, clear.
Because the angle of incidence, there was an angle of incidence, that's why the angle of incidence was having some value, so angle of reflection also having a certain value. Then we have to take two of the statements. The angle of incidence in a glass is less than critical angle for total reflection. No, this is wrong. The angle of incidence in a glass is greater than critical angle. That's true. The angle of reflection is equal to angle of refraction. That is wrong. The light in the glass, the speed of a light in a glass is greater. No. The speed of a light in a glass is equal. The speed of a light in a glass is less than the speed of light in air. So these are the two statements. Like angle of incidence is more than critical, and the speed at which the light is moving in glass is smaller as compared to that in air. So for a blue light, the refractive index of a particular type of a transparent block is 1.5. The critical angle of a blue light. So if you need a critical angle, the formula which relate the critical angle, the n is equals to 1
N
over sine
equals
c.
1 over sine c.
Sine c. So refractive index is 1.5, 1 divided by sine c. So we cross multiply, sine c is equals to 1 divided by 1.5. What is 1 divided by 1.5?
0.7, because 666, it's recurrent.
Okay. 0.7, sorry, last what you said, 0.7?
0.7.
Okay. So 0.7, and then we need a critical angle. Just take a sine inverse of 0.7. What is the value for critical angle?
44.4.
So 44.4. Usually you will find if it's better you take a recurrent decimal, because it will make a difference as a in a value for sine. Like you said, it was
You can
0.66.
write 0.66.
Yeah, 0.66. Because 0.666 and then you were 7.
Or
So
we can directly do sine inverse of 1 over 1.5.
yeah. So this will be 40. Sine inverse of 0.66.
41.2.
41.2 degrees. A block is there which is made from a this type of a plastic. A blue light travel in a vacuum. Incident. The angle of incidence is 45. At point P, some of the light is refracted and some is reflected. The blue light is used in this experiment is monochromatic. What is the meaning of monochromatic?
A light with a single
frequency.
frequency.
Single frequency and wavelength.
Light with a single frequency or light with a single wavelength, but don't say light with a single color or a one color. That is wrong. Why it's wrong? Because even colors have different shades and different range of frequency. Like red is not having a specific wavelength. There is a range in which the red color lies. Then calculate the angle of refraction because it's moving from air to glass. So we'll use a formula that sine I over sine R. The refractive index for such type was, I think, 1.5. So this was 1.5. The angle of incidence was 45. Angle of refraction, we don't know. We cross multiply. So sine R is equals to sine 45 divided by 1.5. And then take a sine inverse. So what will the answer? The final answer, like sine 45 divided by 1.5. What's the answer? The final answer?
0.471. The final is 28.
28. 27.8, I think. One student mentioned 27.8. It's 27.8 or you write 28. That's fine. Then on a figure, draw the path taken by a light that passes into a block and a path of a light that is reflected. So first it will refract, then it will emerge out, and then the reflected one. Because the question is partially refracted, partially reflected. This is a question related to a lens, as we did today, the lens topic. Figure 7.1 shows a converging lens with a principal axis. The point label F are the each principal focus of a lens. They just label focus here. On figure 7.1, draw two rays from top of object to locate the image. So first, how to locate an image? First, we'll draw from tip of the object, we draw parallel light ray. From where I should pass through?
To the
Focus.
So it will pass through focus. The second light ray I pass from the center of the lens, where it will move.
It will continue its path.
It will continue its
direction.
path. Yeah, it will continue its path in the position where the two light rays will meet or intersect. That is a position where the image will form. So that's the position where the image will form. Then underline three of the terms below describe the nature of image produced. Like this we drew.
It is magnified, real, and inverted.
So first parallel passes through the focus. One through the center will pass straight. The position where they meet or intersect, that's the position where the image is formed. So when you compare the size of image with size of object, because this is done with measurement, when you compare, it's a real image, because the real image can be but the question is not related to this image. The question is related to the magnifying glass. Like this is underlined 3 terms which describe the nature of image produced by magnifying glass. No, this is not real. This is real image like this, because this image is formed by
The
intersection of the
one
line.
by
That is
magnifying
real.
glass is virtual.
Yeah. The magnifying glass is when the
Visual,
object,
upright, and
when object
enlarged.
is between the focus and the lens, when object is between focus and the lens, first parallel light ray will pass through the focus and one through the center will pass straight. This is the position where the image will form. Like how the image, that is how the magnifying glass works. So we need the magnifying glass. So for a magnifying glass, it is like magnified or enlarged, it is upright, and it is virtual. If the question was related to, like this is related to magnifying glass, but the question, if the question was related to this image which is formed, then it will be a real image. Then we'll compare the size. Is it clear, this one?
Yes, they are clear.
Then why the image formed by a magnifying glass cannot be real? Because this is just our imagination which create the image. When the object is between the focus, when the object is between the focus and the lens, the two light rays will not meet or intersect. So first the parallel light ray will pass through the focus, one through the center of the lens will pass straight. So these two light rays will never meet or intersect. So that's why it will be virtual image. But in this one, this will be a real image, because whenever, even without drawing, I can tell it will be a real image because the object is after 2f. Oh, sorry, after f. Whenever object is anywhere after focus, the image will always be real. If object is between focus and lens, image will be virtual for a lens, convex lens. So in a ray of a light, green light enter a prism as a red light. So we have to, on a figure, draw a path of a green. So green light,
It will
bend more and it will emerge out. That's how we will complete a path for a green light. So these are some questions from exercise 2, light. As it's an important topic, that's why I prefer to discuss this exercise as well. Any question or a doubt related to the session today?
No, sir, Jazakallah.
No, sir, thank you.